Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and cagglers about their journey, experience, and talk all things about data science. Hello and welcome to Chai with my research heroes, CTDS.Show. In this episode, I interview Aman Madaan, graduate student and researcher at Carnegie Mellon University, CMU. Aman has worked across different industries, across different machine learning related use cases, which we talk all about in this interview. He's worked on use cases involving applications at large scale and has recently transitioned into academia. Of course, we discuss about his perspective and his perspective changes from that transition. Aman has also taken the fast.ai course. He's been a fast.ai student. We talk about the course. One of his posts from 3 years ago just became a reality. His project suggestion just led to a paper, a research project about politifying your text, making your text more polite. We discuss all about this project. How have the last 3 years helped make this happen? So without further ado, here's the conversation. Please enjoy the show. I'm honored to be talking to one of, if I may, seniors from the fast.ai family, fast.ai community, Aman Madaan. Aman, thank you so much for joining me on the podcast.
Thanks for talking to me.
So I want to kick things off by talking about your journey. Can you share how did you get interested in machine learning? How did you get started in the field?
Right. So I think as for getting started or my first exposure, it was way back in 2012. So IISc, which is the Indian Institute of Science, they organized something called the Undergraduate Summer School. And it's a week-long program. I don't know if they still have it. But it was a week-long program in which they select some undergrads to come over and then listen to research talks and do some research activities. And it so happened that in 2012, most of the people who organized this program were from machine learning department. So it was very machine learning driven. And that was kind of the first time that, I was exposed to machine learning problems and, the details and the beauty of it. And I think that was kind of my first exposure, and was very, 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 I think it led a lot of impact on me. And then I did an internship at the National Informatics Center in Delhi, which was on community detection in large graphs. So if you have social network graphs, how do you detect communities of people? And I think then after that, I did not do anything ML related for a year. And then in 2013, I joined IIT Bombay for a master's program. And then I took a class by Professor Sunita Saravagi on an intro to ML, and I think that's how I kind of started working with her, and that's when I kind of really started doing ML-ish things.
How were things in 2012? Were you coding stuff in MATLAB, C++? Because many of the audience doesn't remember there wasn't any TensorFlow before 2015. No,
there was definitely no TensorFlow, and I was very interested in 2012. I was very interested in the so-called high-performance computing, which is if you connect a bunch of computers together, then how do you run programs? How do you make sure they scale? So it was lots of C++ and MPI and those kind of things that are not talked about now. In 2013, when I started doing ML, Python was already popular. sklearn was very popular. I think sklearn was already up and rising, and you can tell even now it's like pretty awesome. And if you want to do a lot of stuff sklearn gets it done. So sklearn was still popular. So it was not MATLAB. So I'm not that old.
Okay. This is also one of my personal curiosities. You transitioned into the Bay Area. I'm just curious, as an Indian student, as someone who's from India, did you see any perspective changes? We look up to the Bay Area as they go to area for all tech.
Yeah, I mean so I have not worked in India. So I just got a job in the US and stuff. So I cannot really compare and contrast the work cultures. But in terms of, I would say that yes, there is this image of the Bay Area that it has to be the first at everything, right? So there you see a lot of that. So I still remember when I landed, and then I was going back to the place I was supposed to stay from the airport, and I saw there was a billboard that talked about an ML company, and it was kind of very new to me. People talking about these things, and advertising about machine learning. I used to think who would be interested in this stuff, and everyone supposedly in the Bay Area is interested in machine learning. Um, so I say there's definitely an attitude to adopt things and to play around, to experiment. Of course, when you do this a lot, there is a lot of hyperbole that comes with it. So and that kind of, I think, is part of the process. In terms of attitude, I think definitely people do try to adopt, I think, to whatever's, and they keep an ear out for whatever's the latest and the greatest, and try to kind of see how can they fit that in. And sometimes it's for good reasons, to solve a new problem. Oftentimes it's for bad reason, as in how do I add a keyword to whatever the pitch I'm giving to the VC. So you see things like machine learning at scale in the cloud for self-driving cars with Bitcoin, just like a bunch of jargon. So I yeah I think so. Short answer would be adoption. I thought was very and keeping an eye out, an ear out for new things.
So the Silicon Valley TV show isn't too much of fiction, somewhat, but not completely.
Yeah, I watched a couple of episodes and it was too real. I mean, it was like was so cringy. I couldn't watch it because it was hitting home really close. So, but I suppose that's because it's like they've done a really good job of showing it. Yeah, some of that is very real.
That's fascinating. So I was going through your recognitions. You've received many recognitions throughout your work in the industry. You've been recognized with senior ranks. What are your key learnings? Because now you transition back into academia of sorts, if I may. What are your key learnings from industry? You've also worked across different use cases. You've worked on use cases involving large scale applications at Visa. Any key learnings from these?
Yeah, I think Visa was definitely one of the best jobs I think anyone could ask for, because I was allowed to play with data sets at a scale that most people would never get their hands on. So we are think about this. Anytime anyone across the globe swipes their Visa card, right? One row gets added to the data set we had, which
Hmm.
is where did they spend, how much did they spend, what was the category of the merchant, time of the day, location, etc. Right? So we had data set of the orders of billions of transactions, something like 500 billion per year. So it was like humongous. The in the key learnings there with working with this data set were many, but I think a few of them were, I think the first one was so my manager Jagdish Chan, he was supposed to work on a model to predict who's going to spend on, say, Uber next month,
Hmm.
right? So find out the top 1,000 people in the US who are most likely to use Uber, right? So how do you solve this problem? And then he gave this to me, and of course, I wrote 6 pages of LaTeX with all the equations, and he was like, "No, dude, this none of this is going to work." And what ended up working really well was very simple application of base rule.
Interesting.
So of course I cannot explain all the features, etc. But it was really a simple feature set, and the key was to design the features correctly at the right granularity, and then apply base rule. So probability of someone spending an Uber is a function of what else did they do, and if they have, for example, if they are going out on Friday, or if they are renting cars, most likely they do not have a car and they'll buy something like that. So I think simple things work really well. And sometimes only simple things can work because, of course, if you have 500 billion rows that you have to do inference on, you cannot do things which are not scalable. So it has to be something that can be spread across, a cluster of 1,000 nodes or something or whatever.
Were you also involved in the engineering side of things after you created these features? Were you also involved in how can they optimally deploy these?
Absolutely, yeah. So we were a very small team. In fact, me, my manager, and one other person, Kingdom, uh, we were we started kind of this whole initiative, and my manager led it, of course. So we were responsible for everything from design to. We were one of the first teams at Visa that developed things in Spark, Scala Spark, which was kind of an up and coming technology at that time. So that also was very, I think, a key learning for me. So yes, we definitely had to worry about all those things.
I
And
guess it's a struggle for Zoomers, people who spend a lot of time on Twitter, to not go to the biggest model that they know of and try that as a solution when they get their first project.
yeah, that's I think that's something that was ingrained in me by my manager. And this could be probably something that's an artifact of working in the industry, because the bottom line is not how you do it, right?
Hmm.
Like no one's writing a paper about it. So what we want is something that really works. And that works for all these different corner cases that you can think of, and it works at scale and all that. So I think when you think of these solutions, and when you have so much data, inherently I think simple things win, because so we developed it, but then we have to do other things. So we cannot develop a system that cannot be maintained by someone entirely new, right? And they may not have necessarily a large knowledge of machine learning or anything, right? So it has to be a data pipeline at the end of the day, and the transforms have to be simple so that they can be debugged. um, at a place like Visa, you cannot really use black box tools. For
Hmm.
example, you cannot just say, this. You give as input a person's spend on the last 1 month, and you get some attribute, say their age or something. I mean, these things won't be approved because you have to explain to not just business people but also to the legal team how is the model working. And if you have a model that's interpretable, say a decision tree, or in our case, a bunch of rules, you can always share those rules with them and say, these are the rules. If you want, we can take some merchants out. For example, we were not allowed to do any inference based on any medical merchants or things like that. Um, but in case of a neural network, it's kind of hard to do. So I think simple solutions win for many reasons, but some of them are just what I talked about.
So I also want to understand. Usually, majority of the people, most of the times, transition from academia to industry. You just transition from industry to academia.
Yes.
Why did you decide to do it?
Yeah, I think that's a very good question. And I think part of the answer is actually very, I would say, straightforward, which is that the plan always was to continue. So when I was graduating with my master's, my original plan was to continue towards a PhD or to join a place like IBM Research. And then IBM Research has this very nice 2-year programs where you work with them for 2 years, and then the expectation is that you'll go for a PhD afterwards.
Somewhat
Um,
similar to Google AI residency and FAIR.
yes, I think they started it. Yeah, so at IBM it's called the Blue Scholars Program.
Okay.
Yeah, but yeah, it's something like the residency. But then I got this job offer from Visa, and of course, it was about applying machine learning, and it was in the US, and all those things. I was like, maybe I'll try it for a year, and of course, that 1 year became 4 years, which usually happens. And but eventually, I think the plan always was. So this was in the back of my mind always, that at some point I would want to go back to the academy and sort of continue. So this is more or less a continuation of the original plan in my head, not so much as a change.
Do you see again any interesting perspective changes, because academics and practitioners don't usually talk that much? They're thought of as different people. Do you see any changes, even though you've just been in for I think 1 month now? Still, any observations?
Oh, I've been in this. I've been at CMU for about a year now.
Okay, sorry, my
Yeah.
information is outdated. I'm sorry.
Oh, yeah, maybe my website is. I'm sorry. But yeah, I think the biggest, I think I already talked about this, but I think the biggest difference would be the bottom line is different for people in both academia and industry, right? In the industry, it's about making sure it works and making sure that all the corner cases are taken care of, because this thing that you are building is going to be deployed. Someone is going to be using it. When you're in academia, you can worry more about the beauty of the idea and is the idea original or not. And you can avoid a lot of engineering challenges by doing, making assumptions, or by using MNIST, for example, just keeping things simple and focusing more on the idea at hand. In the industry, if you are not in a research lab, of course, right? So if you are working in industry, then your delivery, the goals are different, and I think that changes a lot of things for people in academia and industry, because you cannot hand wave engineering in the industry, and you cannot hand wave theory in academia. Um, so I think that makes a lot of difference. I think
Yes,
one. Sorry, go ahead.
please go ahead.
I think one other difference that I found was that people in the industry sometimes are a bit too suspicious of the new cool things on the block.
Yes.
So if there's a paper, and if it looks very complicated, in my opinion, a lot of the people would shy away from thinking about adopting it, because they might think that it's just for the sake of writing a paper. So there's some sense of suspicion, I would say, on both sides.
Hmm.
So academics usually think that if something is cool in the industry, it's just engineering, it's not interesting, and vice versa. So I think that's I saw that in the industry, and I found it to be true in the academia.
I think
People
it
underestimate to some
it
extent.
also varies from company to company. So some lean startups sometimes are more adaptable to these things, but I
Oh
guess
yeah,
that also changes with the scale.
absolutely. I think that's very true. And so when I say industry, I talk about the good old big companies,
5,000 plus
and
employee companies.
yeah, and probably also not companies that have very dedicated ML facilities like Google, right? Because there might the I think the attitude is more open. But there is a long tail of companies which are not Google or Facebook, right? And those companies have huge machine learning use cases, and they're investing a lot of money on machine learning. So IBM sort of, I think, is a player, but Oracle is a good example. Visa is a good example. SAP, all the biotech companies, all the finance companies, Credit Suisse, banks, big banks, Wells Fargo, for example. Even fast food chains, McDonald's, KFC, they have dedicated ML teams in their
Hmm.
IT teams now, or they are putting out money to build such teams now. So I think there's a lot happening, but so I think most of what I comment are about those places. Yeah,
And I think the truth lies somewhere in between. One should be skeptical of both sides a little bit, and truth is somewhere in between.
yeah, I suppose, yeah.
I also want to discuss about a course you've taken. It's sort of the rebel, which has really at least shown me that I don't need to pursue a traditional path in order to get. I've only gotten somewhat good, but I know you. It had a big impact on you. I'm talking about fast.ai. Can you share how it impacted your journey? You were also active, I think, until last year for the part two of
Yes,
2019.
yeah.
How has it impacted your journey?
So I think so. But I took the first course in 2017. I think it was part two that I took in person.
The TensorFlow and Keras.
Yes, yes, and I think it has it was just amazing. And I think even from the first class, I could see that there's lots of philosophical sympathy between the way Jeremy teaches and the way that I learn. So very hands-on and the big picture stuff first, and then kind of slowly getting into nitty-gritties. And I really enjoyed it. And so what had happened was that I had graduated in 15, and when I was still at IIT Bombay, there was no course on deep learning, and
Hmm.
we're talking about 5 years back. Um, And then so I moved to the Bay Area, and so I kind of I was rusty on these things. So Jeremy kind of the course helped me in getting started in picking those things back up and in applying those things to real world use cases. So it was tremendously helpful, the whole hands-on approach, and the fact that Jeremy was covering things that people would that was really state of the art at the time, and I believe that still is the case. That while the material is meant for beginners, in no way, shape, or form is it diluted in the sense of the number of things you cover. So if someone's really interested in say GANs, at that time Jeremy taught WGANs, and you you could implement the paper if you just followed the class. And I think that's tremendous, like creating such a learning environment for beginners and for all levels of people. People who have done machine learning, published papers, they still, I know for a fact, they learn from the course and they enjoy it and they go on and improve. So it was tremendous help.
Some bad students like me never graduate. I'm still stuck in the course, still making my way through it. One of the advices from Jeremy, the best advices or the most highlighted advice by him is to find a project, stick to it. You posted about this idea Jeremy highlighted 3 years ago. Why didn't you give up? Why didn't you give up on the idea? You still, I think, you still stuck to it.
I kind of did give up, to be honest. So I think it happened like this. So Jeremy taught image style transfer, which was, I think, a popular problem. And then because I'm a text person, I, of course, naturally I thought about how do you do this for a piece of text. And then the post was about, if you do it for a text, what would it mean, etc. And it got some attention, and some people pointed me to some links that people are already thinking about those problems. Of course, I mean, I think it's a pretty low hanging fruit. So but not a lot had happened. And so I kind of read a few papers and I moved ahead of the problem. And then when I joined CMU, we had to do this course project for a course taught by the awesome Graham Newbeck on machine translation and seek-to-seek models. And then I got in touch with this amazing team, which is Tanmay and Amrit, my first co-authors. And then we met Shimai, and Shimai is kind of one of the leading people in academia on style transfer.
Okay.
So and then of course we were discussing that I want to do something like this, and then we teamed together, and we were able to kind of pull this through. So I think I was able to do it only because of a great team, and because I was given all the time in the world and some motivation to kind of keep pursuing this. So I think it's important to pick a project, but unless you need the right environment to kind of pursue it, because ideas like this, I think in the industry it's very hard to spend 3 months
Absolutely.
working on something like this. I mean, unless you're working at Grammarly or something, I guess. But
3 years is sort of a decade, more than a decade in deep learning world. What do you think? What would be the key factors that has changed or has allowed this project to come to, apart from the amazing team?
I think I would say to some extent the fact that we transformers came along, and that's what we use in this project, right? And that happened after I thought of this. I've kind of planned on doing this. So we definitely saw that we get huge gains because we have this extremely powerful self-retention model, aka transformer, working on it. So I would say maybe without transformer, things would not have worked as well. So that would be a pinpointed objective answer. And I think to some extent in general, what has happened is that it has gotten increasingly simpler or to experiment with deep learning pipelines, thanks to things like PyTorch and fast.ai. So, for example, in this project, we needed to train a lot of classifiers to evaluate a system. For example, given a piece of text, is it polite or not? Is it positive sentiment or negative sentiment? And that has to be done on a lot of data sets, a lot more data sets than we show in the paper. And fast.ai was kind of a total blessing, because you could train a test classifier in like 6 lines of fast.ai code, right? Similarly, PyTorch allows you to tweak things and kind of play on with small data sets without having to worry about a lot of setup.
So you team PyTorch and not team TensorFlow?
Yeah, I think most of the people at what I see at CMU, unless they are working with Google, so there are some people who have internships at Google or who have kind of a part-time PhD, I think, set up with Google. They use TensorFlow a lot. But
Do
other
you
than
sometimes
that,
secretly catch them working on PyTorch during late night hours in a secret
maybe
corner?
I am not, but I'm pretty sure that, and I'm pretty sure they do, because there are some things that I cannot imagine like people would bother even working with TensorFlow on. But I mean, things change, so I'm sure TensorFlow would change, for the good in some years. Who knows? But I think for now, in the academy at least, I see the clear winner is PyTorch.
Okay. Um, so we've been teasing the project for the audience. If you'd like to look up the paper, it'll be there in the show notes. But if you're too lazy to scroll, you can just Google politeness transfer or tag and generate approach. To set the stage, why is generally style transfer speaking for text a tough problem?
I think it's a hard problem for the reason that many or all NLP problems are hard, which is that text in general is hard, and there's lots of, you say things in a subtle way, and there are nuances when you type as opposed to when you say things. So I think those are all intricacies of language. But in particular for style transfer, one of the biggest challenges is the phenomena of so-called content preservation. So, for example, suppose you have a sentence that says, I hate this pizza, right? Now, this sentence is talking about pizza, right? So, the content of the sentence is pizza. And the sentiment of the sentence is negative, and it's captured by the word hate. So, this sentence, I hate this pizza, is kind of, there's two things in it. Now, when you want to convert the style of this sentence to positive, you would want to say something like, I love this pizza, right? However, in the process, you cannot ignore the pizza. So you cannot say, I love this tea, this cup of tea or something. So this phenomena is kind of hard to capture and to enforce. And in general, I think that's what makes a lot of these problems very hard. So there has been work in, for example, disentangling the content and like the style vectors in a latent space, and then try to single out the content and then add style on it and stuff like that. So we do something similar, just that we do this at a surface level. So we try to identify the words that can indicate style and isolate them, and try to leave the content alone.
So
So,
hence the title. You're tagging them essentially and then
right.
generating.
Right. So the idea is actually very simple. That suppose we are given 1,000 sentences that we know for a fact are all polite. Say a human hand labeled them, and we know for a fact they're polite. So what we do is we sample 1,000 sentences, which from a random corpus, right, which are not necessarily polite, but most likely they are just neutral. And then we find out phrases that are more likely to occur in the politeness, in the polite set, as opposed to the random set. And those phrases would be things like please, thank you, kindly, could you, etc., right? Because those would of course be more prominent in the politeness set.
Yeah.
So when training, the way we train is we first of all identify such phrases and we replace them with a tag token. And then we train a second model to fill these tags with these polite phrases. So hence the name, like you said, tag engine. Right? Yeah.
And I believe you had a very interesting data set as well for this case.
Yes. So the data set was the Enron email corpus. So Enron was an evil giant company 20 years ago. They closed on 20 years ago. And somehow, because of some litigation, etc., the email corpus was made public. So you can download in all of the company's emails. And so the interesting point is that politeness is usually only important when there is an act of saving face involved, which is to say that when two people are having a conversation, and if I say something to the other person in a way which helps me in making sure the person saves their face. For example, if I say send me the data, right? Uh, that sounds a bit like an order, right?
Yeah.
If I say please send me the data, that's kind of
Nicer
softening
order.
it a bit. And that's kind of, making sure the person does not think that I am socially superior than them. Similarly, there's another politeness strategy of adding "could you please." Similarly, there's instead of issuing a direct order, the phrase "we" is used. So, can you send the report as soon as possible? Can we please get this done as soon as possible, right? So, if the moment you move from a "you" to a "we," the responsibility is sort of collective, and that helps, the person is, and kind of, makes it less direct and less rude, so to say. So it can only happen when a request is involved, and emails are all about two people, of course, having a conversation, and one person asking other person to do things, right? So that is why we had to use emails, and that is why, we had this corpus. So that's the background behind.
Did you have to filter out emails as well? Some might not have been so polite, or did you just pick the complete corpus?
No, we did select a subset. So we had a politeness classifier,
Okay.
um, which we refer to the references in the literature. Christian from Cornell, they have a politeness classifier, as well as Mohit Bansal's team from UC. They have done some work on politeness class. So we use politeness classifiers that exist in literature to label this corpora with a politeness code. And then we take sentences that were rated as the most polite by the classifier as, our set of those sentences from which we will learn the phenomena of politeness.
Do you think this can be also moved to an unsupervised direction by just let's say training a transformer model, generating more text, and just classifying it, and again building this politeness stance on top of it?
Oh, that's a very interesting area. So what you're suggesting is that if you train a language model on, so suppose we get a large amount of text from somewhere, and suppose we know from this classifier that all of this text is polite, then we can use something like GPT-2 or fine tune
Exactly.
something like GPT-2 to generate new polite text,
Yeah.
which will kind of loop back to the system and helps us in learning. I think that's a very interesting idea, and I think that's a very good point. So maybe you should try it, and or if you need any help in setting it up, let me know, and I'll be happy to. The
That's
only
very
the only catch would be that I'm not sure if so the whole name of the game is that will such a system learn new phrases, right? So if you have a set of tags that tell you how polite that kind of indicate politeness. So let's go back to our example of 1000 sentences. From those
okay.
1000 sentences, we figured out that these 10 phrases indicate politeness. So the phrases could be please, thank you, kindly, could you, thanks,
Yeah.
etc. Right? Now the question is, if we employ this strategy that you just came up with, will our set of tags go from 10 to 15? You see what I'm saying? That
I
makes
do.
sense?
Yes.
Yeah. So do you think that will happen?
Given so my argument would be given the given how effective GPT-2 or these mammoth like transformer models
Sure.
have been, it might work. But this, like fast.ai says, there's just one truth to such questions. Just give it a try and see where it goes, I think.
Yeah. I mean, it's a good point. It's a good point. So yeah, like I said, if we can see, if somehow the set of tags can go from 10 to 15, so if GPT-2 is able to generalize this phenomena, right, and is able to generate more conversations, or is able to figure out that, because GPT-2 is trained on basically the entire text, entire web, right? So
Yeah.
if it could pull other sentences, like those sentences that use slightly different politeness strategies, I think that could be a very good experiment to run. So I'm
I
looking
wonder
forward
if
to.
someone from the audience will pick this up. But another interesting question that I try to think a lot and ask my heroes about is something that I've learned through Fast AI. People who don't have access to huge resources that are independent researchers have maybe just one gaming GPU. How do you think they should approach such problems? Do you think they can contribute to these results as well?
I think that is, to be honest, it's much harder to do something like writing a research paper unless you have someone from the academia working with you, and that is something that I have realized more and more. as I've spent time at CMU, right? It so if you are if what you're really after is writing a paper, then the easiest way to do go about it would be to build up some skills that you can bring to the table, and they could be PyTorch skills, absolutely, right? And they could be skills in just that you're well read and in a specific area. Say, for example, if you are interested in generative models, you've read the last all the 50 papers from ACL this year that talk about generative models, or at least have gone through them. It actually doesn't take that much time if you just skim through them.
Depends
Um,
if someone is as knowledgeable, as smart as you or not. For me, it
no,
might take 10 days.
if you, if you just read those papers, then a lot of them are just deltas over, what people have done. But so if you have those skills, I would say a good strategy, and I don't want to give a hand wavy answer. So this would be the strategy, and build some skills, and approach a professor or a research lab or a senior PhD student, and say you've been working on this idea, and can you help them with something, or can they help you in pursuing this further? So if you bring something to the table, people are usually more willing to kind of meet you midway and collaborate. So I would say if the goal is to write papers, then that's the I would say the easiest way out is to kind of find collaboration with people who do this for a living, right? Which is writing papers.
But taking a step back, if it was just trying this idea that I just threw off there, people with just access to one graphic card, maybe to just 128 Ti, do you think they can contribute to these experiments? What should they constrain themselves to some sets of problem? Because for transformers, you have to shut down the batch size to one most of the times.
Yeah, I see. Yeah. So with one GPU, you can fine tune GP2 medium with a batch size of two, with a 2080. Or I do that all the time. But of course, not to just for it's just to be funny. But seriously, I think a lot of the problems you can. And actually, I was at one of the mentoring sessions at ACL, organized by Siva Reddy from Mila, and Chris Manning dropped in, and then someone asked him a similar question, which is, how do we compete with the industry as students in research labs? Because whatever you do, Google can throw 2,000 TPUs at it, or whatever. And what he said was, and I liked his answer. His answer was that if you are a student of aerospace or mechanical engineering, your job is not to make a new airplane. Your job is to pick something, a small part of the airplane, and then further pick a phenomena or a small subpart and try to push it. So what he said was that most of the interesting ideas in the last 1 decade, and this is a person who has gone through every interesting idea ever.
Absolutely.
So he said um, all the good ideas have, in his opinion, have been those that could have been easily developed end to end on a single GPU, or using very small resources. So I think interesting ideas are usually, you don't need 50 GPUs to run them. But if, for example, if your area of interest happens to be fine tuning large language models, or making a new GPT or something, then I would say unfortunately the resources are a constraint. And then maybe reaching out to one of these places that have this kind of infrastructure might be a good idea.
But like you said, most of the times, interesting research ideas are just a small, interesting twist, interesting delta to recent works.
Yeah, that happens a lot, and I would say most of the time that is what happens. Like, I don't think all the papers are just creating something from scratch. At the recent paper we have, we are not creating things from scratch, and we cite a bunch of papers who do very similar things. We just do these two things differently, and that's why it works. And I think that's if that's fine. Yeah.
Taking a step back, how do you generally approach research problems? Maybe if you could talk about your work on Politeify, or just take as an example the naive idea that I just proposed. If you were to take this as your research interest, how would you approach it?
I think so. One of the first memories I have of one of the talks at ISC was someone was talking about NLP, and they said never ever do anything that does not have a data set. So whatever you think of, I think unless you work, and I work on very applied stuff. Um, so unless if you work in say theoretical stuff, you can just do everything on the paper and then run it on MNIST or Cipher or something, and it's fine.
Yeah.
But I would say get data set. So, for example, for the problem that you just discussed, um, you would need to think about the data set first, and I think that's the variable that I personally like to fix first. What is the data set that we are working on? After, of course, we decide on what is it that we're working on. So, what is data set? What is the size of the data set? And then kind of load it in some Jupyter notebook or, Colab notebook or something, and making sure that, you see at least 50 rows of the data set,
Hmm.
right? I'm pulling the number out of thin air, but I just see so many times that people use benchmark data sets without ever seeing a single row of that data set, and it works. But I think this is a habit that kind of was um, taught to me by the industry, because if you are working with real world data sets and if you're shipping real products, there would be so many corner cases that you would have to first of all look at your data. Secondly, whatever you're deploying has there's real money, people are betting on it, right? So you cannot not do that. And so I think this habit of going through data, and it actually feels, it may feel laborious, and sometimes it is, but I think it helps beyond anything. So I would say, like, fix on the data, then look at the data set rows. So for example, in your case, if you fine tune GPT-2, so you run this politeness classifier on a large corpus, you get tons of data that you think is polite. Now you would need one more classifier to figure out which of these sentences are request. But let's say you've done that, and then you fine tune GPT to generate new text given some seed word. Then you'd have to, I would say, go through some generations yourself, even though you may have some metric, say, which is indicating that the outputs are good. But I would say, doing the job of going through data.
So manually reading the generated,
Yeah,
or
it's
just
like,
the data set.
yeah, I would say if you're doing applied stuff, then there's no way around it. It also helps you, in like making sure you don't do any mistakes when you're reporting numbers, and there's no obvious phenomena that you're missing. So, for example, when the first versions of this politeness thingy that we done, um, what it was doing was it was adding a please in front of every sentence.
Okay.
And if you throw it to a classifier, the classifier would say, yes, these set of sentences before you ran your system were only 30% polite. Now
Hmm.
they're 99% polite, right? And you could write a paper about it. And of course, that would not be, maybe it'll get accepted, if someone's only looking at the numbers.
But
But
also it'll end up in a trending tweet that like actually end up exposing, maybe not. What
it's
do you
like
say?
it'll be, and that actually happens a lot with site transfer systems, because there is no real way of measuring success, right? So if you add for example, if you are given a bunch of negative sentences, and if you add a lot of positive words, random positive words, loved it, and do not change a thing about the sentence, it would be
Hmm.
gibberish. I hate this pizza, love it, awesome, amazing, right? Makes no sense, but a classifier would think it's very positive.
Hmm.
um, so I would say going through data helps a lot, and after that, having people to discuss is very important. So if you are an individual researcher, fast AI, something like fast AI was very helpful for me, not just because of the content, but also it gave me a platform to discuss things with people. Discuss these new research ideas. So people, there are meetups and all those things, especially in the world of Zoom. I think
Yeah.
a lot of the conferences are very accessible. So, for example, ICML is happening right now, and the registration fees, I think,
hundred
could be
dollars
free if you're a student. But
For students, it's pretty cheap. I think for people in industry, it's $100. I think, which is very
oh,
less.
I see. Yeah, I think for students it was like 25 or 20, something like
I
that.
think so.
Yeah, so you can watch all of these things from the comfort of your home, and ping people on Rocket Chat, people you want to talk to, and people are usually more open to speaking than you would think. And I made this bad assumption a lot that why would this person want to talk to me, etc. But over the years, if you have something interesting to say, people would always want to listen to you. So I would say that's a good way of going. If there's a conference coming up, sign up for it, go to the Rocket Chat, see what people are talking about, ping people, talk to them, try to set up Zoom calls. I think all of that would help. So just try to be more connected and, keep an ear out for what's happening in the world.
I think so. Aman's ideas are, of course, much better than the one that I just threw out. So that was a proxy to understanding your process. But I think you pointed out an interesting fact, which is maybe for style transfer for images, we can't, as humans, inspect it because everything just looks interesting for images. But for text, I guess as humans, we can read and classify it, but that's also challenging since it's difficult to make models do that. Not accounting for transformers.
Yeah, I mean, say even for images, I think so. It boils down to, even for text, it boils down to having human judges, right? So I don't think any of the automatic metrics are very good at figuring it out. And for images also, I think if you will need to find human judges, but maybe those human judges would need to be more trained. So, for example, if the style transfer system claims to convert an image to, say, that of a famous painter, say Picasso, then you need someone who has really studied Picasso to tell if this painting could have been made by Picasso. For our problems, you can just hire research like a student to do the evaluation. So I still think it boils down to the same thing, but just you need much more expertise to figure out if the style transfer is correct.
So this is usually a question that I end on. It's a very broad question, but every time I get new perspectives on it, what would be your best advice for someone who's just starting their machine learning journey, or maybe someone who's just signed up for fast.ai course?
I think my number one advice, and I think this is something that Jeremy also says a lot, would be to not be scared of jargon, because people have a habit of throwing out jargon for whatever reason. Maybe it helps them think, maybe it helps them look cool or something. But as a beginner, I don't think one should be intimidated by any of that. And I think a lot of the good ideas, they are at the core. Once you spend some time on them, they happen to be simple, or you would be able to make some connections if you gradually try to learn them. So none of this is it's, of course, I also do not want to trivialize it by saying this is all or use the cliche, this is not rocket science. I mean, this is cool stuff and people spend a lot of time doing these things, but one should not be frightened by the jargon or the Greek symbols or any of that, because I see a lot of the people, they just give up because of these reasons of just not being very intimidated by what's happening. So
Aman, before we end the call, what would be the best platforms to connect with you or follow your work?
I'm on Twitter, like everyone is. So I would say Twitter is a good place if you want to reach out to me. So you can DM me if anyone wants to, if it has any questions about the talk you just had or anything like that. I would say send me a DM on Twitter, or my email is on my website. So feel free to reach out to me. More than happy to.
Both will be linked in the show notes. Aman, thank you so much for joining me on the podcast, and thank you so much for your contributions to the community and the field.
Thanks for talking to me, Sam. Really good talking to you.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review, or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.